Hi all. This demonstration video is the first of three. Um, we, the rock cycle activity, which is explore one under Earth's materials, is very, very long. If you've had a chance to look through it, you'll notice that it's really long. So I'm breaking this into three chunks, and that way you can kind of watch one. You can do parts A, B, and C. We're going to come back and we'll do part D, and so on. The actual activity, I'm going to go ahead and assign it tomorrow and the next day, for depending on which class you're in. It will not be due for a week, so you'll have a little bit of time, and we'll be talking about it throughout. But basically, this is a model of the rock cycle, and it's a very cool demonstration. It's one where this is definitely one where I wish that we were in the classroom together. Lots of things that are great to hold in your hand, really look at up close. That obviously it's kind of tough to do here virtually. But what I will do, first I'm going to sort of give you the lay of the land of what I have here, and then I am going to do a microscope video of these three types of rocks so that you can look at them up close. SubScopes does ask you to compare the fake rock we're going to make with the actual thing, so it'll be helpful to be able to see it. Just to orient you, though, a little bit to what I have. As far as the rock cycle goes, there are, of course, three different types of rock, and I know we've talked about this kind of a little bit in class, so hopefully it's not completely new to you. But again, we have sedimentary rock, and this is sandstone. You can really tell. You can see the real distinct layers in it. If you could feel it, you would notice that it has a very sandy texture. There's little pieces of it that can break off very easily. So this is a sedimentary rock. This is pretty much the quintessential sedimentary rock. The igneous rock that I have is called diorite. Usually forms as a magma intrusion, I think. It has pretty distinct crystals, which hopefully you'll be able to see in the microscope video. Very kind of typical of igneous rocks. And then finally, we have a metamorphic rock. It's spelled Gneis, but it's pronounced nice. And gneiss, I believe, is formed from sedimentary rock. So it's a really good example of what we're looking at for this particular demonstration. Now, this demonstration uses all kind of household stuff. So if you have these materials at home, please, by all means, and your family's okay with it, of course, feel free to give it a try. It is kind of neat to do it this way because it does help you kind of visualize something that normally you would have to observe over millions of years to see in action. But what I have here is I have cheese. This is a cheese grater. Any grater would do, including a box grater. This is just easy to hold and feel that my webcam can pick up. This is my analogous rock. This is a piece of wax. Okay, so it kind of looks vaguely rocky, but it's a piece of wax. And then I have a plastic bag. I've already ground up some wax of different colors, and I put it in there so that you can already kind of see that there's kind of a blue layer down here, and kind of a cream colored layer, and then a pinker layer, and then a white layer here on top. So we'll come back to this. This is going to represent the ocean. So this is going to represent like a stream. And of course, this is a rock. And this is going to represent a weathering agent. Okay, so if you'll notice, part A is talking specific about weathering. Part B talks about erosion and deposition. So in case that's confusing for you, there's going to be a whole scope where we just talk about weathering and erosion. So you're going to see this again. But one thing that is important to keep in your mind is just the fact that when we talk about weathering and erosion, they are two different processes. And it's easy to get them confused because they often do happen together. So it's kind of hard to tell where one starts and the other stops. So, when the way that you think about it is weathering is the process of taking a piece of rock or any other material and breaking it from a big piece into smaller pieces. Erosion is the process of taking those pieces and carrying them somewhere else. So erosion is where we usually are really concerned because erosion means that something that was here is being taken away. And when it's something valuable like soil, that's a real problem. And when we say that erosion causes certain formations to form, that is true, but it's the taking away that causes it, not the actual breaking down. The actual breaking down is slightly different. So we're going to weather this rock right now. So we have this little chunk of wax, like I said, and I'm going to put it here in my cheese grater, and I'm going to weather it. Now, the things that weather actual rocks are probably not unfamiliar with you. If you ever, like had a Jolly Rancher, you notice that like as you're sucking on that, the edges gradually get worn off because little bits of it will be worn down by your saliva and the friction with your tongue and all that. So Same kind of thing here. So this is meant to sort of simulate, rocks banging together that might cause them to break apart. Maybe wind blowing by could if it's a really strong wind, I guess, and not a very strong rock, it could blow something into it that could break a piece off. Ice especially on top of mountains, ice is a big factor. Water will sort of seep down into cracks, and then when it freezes, it expands, and so that causes rocks to get much bigger, and then little pieces will break. So any of those things could be considered a weathering agent. Okay, so if you look at part one, there are two questions there. One is asking, what's an example of a weathering event? The other one is asking, where would this happen? So in order for something to grind down, it has to be exposed to the elements. So hopefully you can figure out whether it's going to be something that happens inside the earth or outside the earth. I'll just say there's not a lot of weather or water inside the earth. Okay, so hopefully that will help you. So those questions are fairly simple. All right, part B talks about the erosion and the deposition. So that's where, I've used a blue piece of paper. And what I wanted that to do is represent a stream. Okay, so water in just a little river. And little rivers lead to big rivers, and big rivers eventually lead to some body of water, usually an ocean. And when they hit that, it could be a lake. But when water is streaming down through a channel and then it hits a big body of water like that, it has to slow down because it's basically running into water that's standing still. So you can imagine if you were running down the stairs, there was a whole crowd of people at the bottom of the stairs. When you got there, you'd have to slow down because you would have to make your way through a bunch of people. When water slows down like that, it can't carry as many sediments as it did before. So what happens then is as it slows down, it will start to drop all of the little bits of rock and little bits of sand that it's carrying onto the ocean floor. So that's what this is meant to represent. This is deposition right here. Okay? And there's no questions you have to answer about this. You're just really supposed to observe it happening. Okay, so as more sediments deposit, they kind of settle out and make a nice flat layer. And I know that this is kind of bright, so it might be harder to see. But, again, we have a layer down here at the bottom that's a little bit kind of a bluish gray. And there's another layer here that's just below that is more of a cream-colored white. Let's see if I can get a little closer. It's hard to get into focus. But you can see there's definitely a pink layer in here and then a white layer on top of that. So I made 2 bags of this together so that I could demonstrate this for you. Part C goes into going from having just, a whole bunch of sand at the bottom of the ocean to turning it into a rock. All right. And it's not a really hard process to understand. As more and more layers kind of fall down on top, the layers at the bottom get smaller and smaller because they're getting pressed down by the weight of all the rock on top of them. Not only that, but there's also an entire ocean on top of them. So that adds another layer of weight. And really, whether you believe it or not, the air above that also presses down on all of that. So over time, you have a lot of pressure that builds up on these poor pieces of sand here at the bottom of the ocean. So in the classroom, if we were doing this, you would basically sit on this to make it as flat as possible. Another thing you'd probably do is use a real heavy book. So this is my Tarbuck and Lucan's Earth Science textbook in college. So push that down. Okay, so over time, it would get a lot flatter than this. Okay, so this is not a great example right now, but I did do one ahead of time because I figured doing it a cooking show would be the better way to go about it. And I've broken it for you so you can really see across the bottom. So notice I really did get that very flat. So we stood on it to make it squish. And you can see that it's still falling apart. This, just like this sandstone, the real sandstone is kind of loose. So if you're messing with it, you could break that apart fairly easily. Same with this. Okay, there's chunks of this that are still falling off. But they are cemented together somewhat. The whole thing's not falling apart in my fingers when I hold it like this. What happens in the ocean is that you have minerals and salts and stuff that get down in between the sand and they act as a cementing agent. And they just hold it together. So that's why you end up with it pretty dense, like something like this. All right. So what I want you to notice about this when I look at it sideways is that you can really clearly see this gray layer here at the bottom. You can see that there's a layer above that that's a little bit whiter. You can see the sort of pinky layer through here, and then, of course, the white layer on top. Question, in the STEM scopes, it's going to ask you to do a sketch of what you see, and you can draw mine, draw that. And then it's going to ask you to compare this rock with the real thing. So, in other words, what do you notice about these two things that are the same, and what do you notice that might be different? Okay, so you're going to do that, and then you're going to go through. What we're going to do is we're going to take kind of a piece of this and put it on the plate. So that's what they're asking you to do in step 6. And there we go. So here's a little piece of the rock. We're going to set it right here so that we have it to go by. And then we're going to take this, we're going to use this to make more rock later on in the cycle. So that'll be what will be in the second video. Now, it is, however, going to ask you to kind of go back and think about this relative to conversations around things like energy and stability. So in question 8, it asks, what is the energy source for this model? So in our case, I mean, for this model, a lot of the energy is coming from me. I'm the one who is, driving this thing and making it weather. I'm the one who's putting the pressure on it and making it squish together. But in the real world, the energy source, again, remember that a lot of this is happening because of rainfall, because of anything else in the hydrologic cycle. So just think about what it is that causes water to evaporate, go up to the top of the mountain, fall, and then freeze, and then start breaking things apart and run down the mountainside. Okay, so hopefully that will help you answer question 9. Especially, and again, think again about the fact that we're talking about the crust. That's going to be a big tip-off as to where that energy is coming from. Now, number 10 is asking about stability and change. Okay, so we had a rock. Here's another piece of it here. It was like this, right? And then it changed and became more like this. Okay, so there was a process here in which we went from a relatively stable state to, a different state. So there was a change, right? So that's what you want to think about. Like, what happened that caused this to become like this and then to leave? And then finally, number 11 wants to know, would you consider this a physical or a chemical change? All right, now I do want to point out that even though these are smaller, they're still made of the same stuff as this. They're just tinier pieces. Okay, so hopefully that'll tip you off as to whether that's a physical or a chemical change. Do remember that on question 11, it's a 2-part question. You can't just answer it. You also have to explain how you know. All right, so that brings us to the end of part C. So I'm going to go ahead and end this video here, and I'm going to start process D in a second video. So I would, go ahead and end this. Go make sure you have all your questions answered for part C before you go watch the video for part D. All right, good luck.